Today I'll be talking about Le Chatelier's principle. So stated simply here, what we're saying is if a reaction that has an equilibrium is altered in some way, that the equilibrium is going to adjust to try and undo what was done there. So this is kind of a way of thinking about it. And so basically there are all these different ways that you can agitate an equilibrium. You can add one of the substances in it, you can heat it up, you can cool it down, you can add pressure to it, things like that. So there are actually like 4 different general ways that we talk about affecting the equilibrium position, but there are also other things that you could do to adjust the equilibrium. And so what this scientist Le Chatelier found was that if you do something and you're kind of agitating a chemical reaction, it's going to try and undo, as I said, what you're doing. And so the first way that you can alter it is by changing the concentration of one of the reactants or one of the products, and just by sort of artificially adding to one side or the other, you cause the equilibrium to shift. And so you should always be thinking about the equilibrium doing the opposite of what you're doing. So if you're adding something, then it's going to try and consume what you're adding. It's going to try and get rid of it. If you're taking away a substance and reducing the concentration, it's going to try and make up for it by replacing what you're taking away. So it's always trying to reestablish that equilibrium and, sort of do the opposite of what you're trying to do. Temperature is a little bit more complicated. What we say with temperature is that, it's kind of like adding heat. And so the easiest way to think of this is in terms of endothermic and exothermic reactions. If you have an endothermic reaction, you kind of can think of it as heat being used as a reactant, because endothermic means that heat is taken in. So if we've got this reaction here where heat is taken in, and you try and add heat to it, right? So we're increasing the temperature, we're adding heat. It's going to shift to the side of the equation that doesn't have heat. So for endothermic here, if it's shifting to the side that doesn't have heat, it's going to shift to the right-hand side. All right. If you've got an exothermic reaction, that's one where heat is given off as a product. Okay, heat there is on the right-hand side, and so if you add heat by heating it up, it's going to try and consume that extra heat, so it's going to go to the left-hand side. Here, if you cool it down, it's exactly the opposite. So cooling something down means that you're removing heat, which means it's going to try and replace that heat that's lost. And so for that first instance there where it's endothermic, if it's trying to create heat, it's going to go to the left-hand side. For exothermic, if it's trying to create heat, it's going to go to the right-hand side. So with all of these, with Le Chatelier's principle, what you're thinking is, okay, how are we disturbing the equilibrium, and what is it going to do as a response? And so we've got these different ones here as kind of practice. So I've got a table here. It kind of shows you what's going on. And so what we've got here in the column on the left is what we're doing to stress the equilibrium. So the equilibrium reaction is written here at the top. We can see this heat is given on the product side. So if heat is given on the product side, that means that it is an exothermic reaction. So we think about these different ways that we can agitate it. If we add N2, it's going to try and do the opposite. So it's going to try and get rid of N2. And so N2 here is on the left side of the equation. So if we add N2 and it tries to get rid of it, it's going to go to the right side of the equation, because that's the side that doesn't have N2 on it. So we say equilibrium shifts right. Okay, if it's shifting right, we're going to ignore N2 because we're artificially modifying the N2. Okay, but if it's shifting right, the amount of H2 is going to go down, and the amount of NH3 is going to go up, because as we're going to the right, we're using up the reactants and we're producing the products. All right, adding H2 has a similar effect. It's going to shift to the right to try and get rid of the extra H2 that we're adding, which means the amount of N2 is going to go down because we're using up the reactants and we're producing these products here. Now, the next one is saying you're adding NH3. So now we're adding one of the products. To get rid of the NH3 that we're adding, it's going to shift to the left, okay, the side that doesn't have NH3 on it, which means that we're going to be using up NH3 and we're going to be producing N2 and H2. And so you can see the arrows go along with that, right? We're going to the left. If you're going to the left, you're going to increase the amount of N2. You're going to increase the amount of H2. Similarly, now if we're removing N2, it's going to try and replace what we're removing. So we take this N2 away. It's going to shift in such a way to increase the N2 to try and counteract what we're doing. So it's going to be going to the left to replace that N2, which means that the amount of H2 is going to go up as the reaction proceeds left, and the amount of NH3 is going to go down because it's consuming NH3, generating N2 and H2. So I think you can follow along with kind of the rest of those there. With temperature, what's happening here with temperature is if you increase temperature on this one, what you're doing is adding heat. And so you look at the side of the reaction that has heat on it. It's these kilojoules here. So if you add heat by increasing the temperature, it's going to shift to the side of the reaction that doesn't have heat on it. In this case, that's the left side of the reaction. So this is going to shift left. If you're going left, then we're generating N2 and H2, so those concentrations are going up, and we're using NH3, so that concentration is going down. And then if you reduce temperature, it's just the opposite logic. If you're removing heat, it's going to try and replace the heat that you're removing, so it's going to try and go to the side of the reaction where heat is coming off. Okay, and if it does that, then it's going to be going right, which means the amount of N2 and H2 are going to be going down. The amount of NH3 is going to be going up. Here's another example of that. So at this point, if it's not filled in on your sheet, I recommend that you pause the video and try and figure this one out yourself. Otherwise, I'm just going to go through it here in just a second. Okay. So the stress we're putting on it first here, it says we're adding N2, so you have to think how it's going to react. It's going to try and get rid of the N2. If it's getting rid of the N2, it's going to this side over here. It's going to the right where we don't have any N2. All right, so we're going to the right. N2 we're artificially manipulating, so we're not going to have a blank for that one. O2 is going to be going down because that's going to be consumed. Okay, and NO being here on the product side, as it's shifting here to the right, the concentration of NO is going to go up. If we're adding O2, very similar to that last one, right? So we're going to shift the equilibrium here. To the right, the concentration of N2 is going to go down, concentration of NO is going to go up. If we're adding NO, we're adding to this side, it's going to shift to the side that doesn't have that, it's going to try and decrease NO. So in this case, it's shifting left to try and get rid of all that extra NO that we're adding. If we're doing that, then what's going to happen is we're going to increase the amount of N2 and O2 because the reaction is going left, and we're decreasing the amount of NO. Well, actually, that one, again, we're artificially manipulating that one, so we put this blank space in there for that. Removing substances, we remove N2. It goes to try and create new N2 to replace what we're removing, so it goes to the left. Okay, if it's going left, we're producing N2 and O2. We're using up NO. Here's one more. So if you want, you can pause the video and try it on your own. Otherwise, I'm just going to talk about it here in a second. Okay, so here's this one. This is pretty similar to the ones that we've already gone over. If you have any questions about it more in depth, you can come ask me. The thing that I wanted to talk about on this one was the temperature. So this one here, we've got increased temperature. In this case, the heat here is on the left-hand side, and so if you increase temperature, you're adding heat. The equilibrium is going to respond by trying to get rid of heat. Since heat is here on the reactant side because it's an endothermic reaction, to get rid of heat, it's going to go to the right-hand side. This side, there's no heat over here, so it will react by trying to go to the side with no heat. So you increase the temperature, you add heat, it goes to the side with no heat, so it's going to be going to the right here. If it's going to the right, we're using up H2 and I2, and we're creating HI. Temperature going down, we're removing heat. It's going to try and fight us by creating new heat, and so it's going to shift here to the left to create this new heat. And if we're going left, we're going to get more H2 and I2, and we're going to be using up the HI. Here's the solution for the last one. Again, it's very similar. If you have any questions on any of these, feel free to come in and ask.